8.3, the natural base, e. So we've got the number e is what we're going to talk about. And so e is the abbreviation for the natural base. It's an irrational number, and it's defined as 1 plus 1 over n to the nth power as n approaches positive infinity. So in other words, as n gets bigger, okay, it approaches infinity. So we keep making n bigger and bigger and bigger and bigger, and eventually we get what's called the number e, okay, the natural base. And because e is irrational, it never ends and it never repeats itself. So we use an approximation of approximately 2.718. Okay? And much like when we deal with pi, we don't often use the approximation whenever we can help it. A lot of times we just leave things in terms of e, in terms of that natural number. So what we're going to do is we're going to go through a few of the examples, and we're going to determine that the number e actually works just like most other, or works like all other variables, in that it follows all of the same exponent rules. So for example 1, simplifying natural base expressions, says simplify the expression. We've got a, which is e squared times e to the 6th power. Well, if I multiply two terms that have the same base, all I have to do is add the powers. So 2 plus 6. So e squared times e to the 6th power is equal to e to the 8th power. Likewise, if I am dividing, instead of adding the exponents, I'm going to subtract the exponents. So for 6e to the 4th over 2e to the 3rd, the first thing that I do is divide the coefficients. So 6 divided by 2 is 3. And then I have e to the 4 minus 3. Subtract the exponent that's in the denominator from the exponent that's in the numerator. So that would just be 3e to the 1st power, just 3e. Okay? And then the last thing, we have a power of a power. So negative 4e to the 3x power. So we have to take into consideration all of the portions that we have here. All right? So we basically have a negative 1 in front of the 4. So this is like negative 1 times 4 times e to the 3x. And then that whole thing then is squared. So I have to use my power of powers, which means that now we have negative 1 squared times 4 squared times e to the 3x squared. So I have to apply the power on the outside to all the powers on the inside. So that would be 1. Okay, so negative 1 squared is just 1. 4 squared is 16, so the 1 times 16 doesn't do anything. And then my e to the 3x squared means that I have to multiply this exponent times the exponent that's on the inside. So that would be e to the 2 times 3x, or e to the 6x. So 16e to the 6x power. So then the last thing we're going to do is use a calculator to evaluate expressions using the number e. So a, e to the negative 1/3, b, e to the 0.7. Okay, and we'll do the b in purple, just to be a little bit different. So e to the negative 1/3, or excuse me, e to the negative 3rd power. So now all these keystrokes are set up for a TI-84. So if you're using a different kind of calculator, you'll need to adjust accordingly. So for a TI-84, you would hit the second function button and then find where the e to the x is at. Then hit the negative symbol. Now be careful that you use the negative symbol and not the minus sign. They are two different things. and then the number 3, and then hit enter. And when you enter that in properly, you should see on the display 0.049787 dot dot dot. Keeps going on forever because it is irrational. For b, we've got e to the 0.7 power, so second function, e to the x, enter in 0.7, although you can probably get away with just 0.7, and then hit enter, and you will see 2.0137527 dot dot dot. Just keeps going on. Alright, so that takes care of examples 1 and 2 dealing with e, the natural number, and then in the next video, 8.3 part 2, we will get into the other examples starting with example 3.